A plotting of graph of quadratic or cubic polynomial is not meant to be done by the students, not is to be evaluated. It is given there downside. See table 2.1. X and y's coordinates are there. Their points are x is equal to -2, then y is equal to 6, x is equal to -1, then it is 0, y is equal to 0, then x is equal to 0, then y is equal to -4, x is equal to 1, then it is -6, or x is equal to 2, then y is equal to -6, likewise 3, -4, 4, 0, 5, 6 are there. If we locate the points listed above on a graph paper and draw the graph, it will actually look like the one graph given in the figure 2.2, likewise this here. This is the origin and this is the x-axis and this is the y-axis. So graph will be this this type of graph will be there. In fact, for any quadratic polynomial ax square plus bx plus c, where a is equal to not 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two shapes, either open upward like this u upside, and downside it is the open downside. On the whether a is greater than 0 or a is less than 0, these curves are called parabolas. You can see from the table 2.1 that -1 and the 4 are the zeros of the quadratic polynomial. Also note from figure 2.2 that -1 and 4 are the coordinates, x coordinates of the points where the graph of y is equal to x square minus 3x minus 4 intersect the x-axis. Thus the zeros of the quadratic polynomial x square minus 3x minus 4 are x coordinates of the points where the graph of y is equal to x square minus 3x minus 4 intersect the x-axis. This fact is true for any quadratic polynomial, that is the zeros of the quadratic polynomial ax square plus bx plus c, where a is equal to not 0, are precisely the x coordinates of the points where the parabola representing y is equal to ax square plus bx plus c intersect the x-axis. From our observation earlier about the shape of the graph of y is equal to ax square plus bx plus c, the following three cases can happen. This is page number 24, case 1. Here the graph cuts x-axis at two distinct points a and a dash, you can say. The x coordinates of a and a dash are the two zeros of the quadratic polynomial ax square plus bx plus c in this case, and you just see the graph here downside given. And case number 2, here the graph cuts the x-axis at exactly one point, that is at two coincides points. So the 2 points a and a dash of case 1 coincide here to become one point a. See the figure 2.4. Okay. The x coordinates of a is the only zero for the quadratic polynomial ax square plus bx plus c in this case. And case number 3, here the graph is either completely above the x-axis or completely below the x-axis, so it does not cut the x-axis at any point. See the figure 2.5. So the quadratic polynomial ax square plus bx plus c has no zero in this case. So you can see geometrically that a quadratic polynomial can have either two distinct zeros or two equal zeros, that is the non-zero or no zero. This also means that a polynomial of degree 2 has at most two zeros. Now what do you expect the geometrical meaning of the zeros of a cubic polynomials to be? Let us find out. Consider the cubic polynomial x cube minus 4x2c to see what the graph of y is equal to x cube minus 4x looks like. Let us list a few values of y corresponding to a few values for x as shown in the table 2.2. Here x table is given for values of x and then y also. -2 0, -1 3 0 0 1 and -3 2 and 0. Locating the points table on the graph paper and drawing the graph, we see that the graph of y and is equal to x cube minus 4x actually look like the one given in figure 2.6. We see from the table above that -2, 0 and 2 are zeros of the cubic polynomial x cube minus 4x. Observe that -2, 0 and 2 are in fact the x coordinates of the only points where the graph of y is equal to x cube minus 4x intersect the x-axis. Since the curve meets the x-axis in only these 3 points, their x coordinates are the only zeros of the polynomial. Let us take a few more examples. Consider the cubic polynomial x cube and x cube minus x square. We draw the graph of y is equal to x cube and y is equal to x cube minus x square in figure 2.7 and the figure 2.8 respectively. Note that 0 is the only zero of polynomial x to the power 3, that is x cube. Also from figure 2.7 you can see that 0 is the x coordinate of the only point where the graph of y is equal to x to the power 3 intersect the x-axis. Similarly, since x cube minus x square, that is x square in bracket x minus 1, 0 and 1 are the only zeros of the polynomial x cube minus x square. Also from figure 2.8, these values are the x coordinates of the only points where the graph of y is equal to x cube minus x square intersect the x-axis. From the example above, we see that there are at most 3 zeros of any cubic polynomial. In other words, any polynomial of degree 3 can have the at most 3 zeros. Remarks: in general, given a polynomial px of degree n, the graph of y is equal to px intersect the x-axis at most n points. Therefore, a polynomial px of degree n has at most n zeros. This remark is very important. You have to remember it, because 1 mark question is coming in the board exam also. Now we will discuss the some solve examples here. Example number 1. Then you have to solve the exercise 2.1. Some questions are there and you have to solve it. We will discuss in the next video about this example number 1, and the next topic will be the 2.3 relationship between the zeros and the coefficient of a polynomial.